Hi everyone, my name is Walter Camaro and I'm going to give you a talk about the activities linked to mapping the habitats under the ECOS project. And this based in a view from the space. I'm going to give you a talk about that and you're going to understand the title. Then the first thing and the most important thing is to understand what is important to mapping the habitats, where the habitats or the key habitats for any kind of species are essential to understand the behavior of the species, because under these habitats the species could cover different kind of necessities, such as food, water, shelter, or only the next in areas. Then it's important to understand how these habitats are, how is the distribution of these habitats, and how these habitats change, or how is the dynamic of those areas in time, to understand why these habitats have a special relationship with the species. In particular, for this project, we have migratory species that are coming to these areas or these habitats in the winter time to cover the food or the water or the shelter, or the nesting areas, as I mentioned before, these particular necessities. Then the idea of the ECOS project with the study of the habitats is to understand the characteristic or the dynamics of these habitats in the seacoast lines, in the IDC, and in particular, these habitats are the key habitats for the Eurasian curlews and for the Greenland white-fronted geese, that are the species of analysis of this project, then to understand why these species are coming during the winter time, and why are they mainly focused in the wetlands, in the floodplains, or in the boglands areas. To understand this distribution and the location of these habitats, and to understand the dynamic or the change of these habitats in times, we decide to use any kind of data set that we can find from open sources related to air observation. The observation is any kind of information that you can collect remote, and we are mainly focusing in the satellites type of air observations. And for the current situation, for example, to understand the map of the situation of the current situation of this kind of habitats, we use the European Space Agency missions, that is Sentinel-2, that is giving us information about the different kind of areas. Why we are using satellite information? Because with this kind of information we can cover large and inaccessible areas that are really hard to access. We don't disturb the species that we are analyzing. Then we can get information of the habitats, and the species could be in the field or could be in the area, and we are not making any kind of we are not affecting any of these species during our analysis. And the most important thing when you are talking about habitats, you are mainly talking about vegetation, because the vegetation is present in the area, and the vegetation is the feature that giving us the information about the habitats. And as the vegetation have different conditions during a year, then with the satellites we can have that kind of information during different periods of the year. That we have the seasonal behavior of this kind of vegetation, and with this we can understand the different kind of habitats, and we can map the classes of habitats in the field. This slide gives you an idea about the kind of information that we can collect with satellites. Then the left side is an image of one of the study areas from the 2022, and the right side is an image from the 2000. The first thing that we can get from this is that the habitat could change in 20 years. The other thing is that not always the condition is the same, the atmospheric condition is the same, and this is important because if we need to map an area or an habitats in an area, we need the same conditions to have a clear idea and to have an accuracy information. And one of the problems and one of the challenges that we have when we are trying to map these areas in this region of the planet is that we have a lot of clouds during the whole year. The first challenge was to find images of moments of the year where the study areas were cloud-free in the different seasons that we were analyzing. The other thing that we can observe is that the information between the 2000 and 2022 is that the distribution of the habitats is different and the accuracy or the quality of the information is different. And this is mainly because the satellites that were collecting information in 2000 in comparison with the satellite that we are using right now to map the areas have a different spatial resolution. Then we could have more accurate information with the current satellites, and we can map a better spatial resolution with the current satellites. And yeah, this is another area of analysis. This is the Dobby area, as you can see in different kind of moments of different moments of the year. And the other thing that we can observe here is that in the right image, with the same area that we were looking before, was the Westford area, we have all the estuary area covered by water. But in the left image, with the Dobby area, we have the area the estuary area that's not covered by water. This is because this is the other kind of information that we can get from the satellite. We can get moments of the day, of the year, from different kind of images where we can observe when the tide is high or low, and we can observe the different kind of conditions where the habitats are present at the year. Then we can observe the different kind of condition of the vegetation, but we can get information that is covering moments of the year, of the day, where the tide is low and high, and that is really important when we are talking about our species that are mainly focusing this kind of wetlands, of this kind of habitats. Then the first part I was mentioned before is the idea of this project is to map the current situation and to monitoring and to see the dynamic of the habitats. And to map the current situation, we use, as I mentioned before, the open source observation, and we use an approach that is mainly based in machine learning. And for this, we have to collect information from the Earth observation from the satellite, and we need to collect some information from the field, because obviously the satellite could give us the distribution of the habitats, but without information in the field, the satellite cannot know what is the type of habitat. Then we need someone that is collecting this information in the field. We feed the model with this information, and we can have a map like this map that you can see in the slide with the different kind of classes of the area. This is an example of the Baltic area. It's one of the study areas, and these are the main land cover class that we have over this area. The other thing that we have here is the idea is not only to understand the current situation, but the other idea that we have, the other end of the ECOS project, was to understand the distribution of the change of the dynamic of the habitats during time. Then for this, we have to look back in time, and we can get like satellites with enough spatial resolution to understand the change in the habitat in the last 3 decades. Then for that, we go to the Landsat constellation, Landsat missions that give us information from the areas from the last 3 decades. Then we designed a change detection algorithm to understand any kind of potential change of the area, to understand the dynamic or the change in the area in the sites. And with this model, we can identify if we have different kind of types or different change in our habitat in our habitats. Then this is the scheme that we use to create the habitats of the current situation. Then, as I mentioned to you before, we have the input data that is mainly the Earth observation, open source observation datasets. We subset, or we code the the initial input data sets over the area to focus in the areas of analysis. We calculate some radiometric indices that are giving us some key information about the vegetation condition. I'm going to give you an example about that radiometric indices that we use here in the next slide. And as I mentioned to you before, we get some field surveys that were collected for the people that were tagging the data sets. They give us information about the fields and about the type of or classes that were in the field, and we use this to map our areas. Then we upload the machine learning approach, and we get the habitat and land cover mass for the field sites for the area that for the baseline year. That means the year where we collect information where the birds were in the field. As I mentioned to you before, these are the radiometric indices that we use to map the areas. Normally, these satellite images are coming or are giving the information in different kind of bands. That these kind of bands are related to the electromagnetic information that is collected by the energy that is coming to the air and is coming back to the satellites. And I'm not going to give you this kind of deep information. I just give to give you an idea that we have different kind of bands, and when combine these bands, we can have different kind of index. The first index, that is the widely index used in any kind of vegetation analysis, is the normal different vegetation index that gives us an idea about the condition and the seasonal variation of the vegetation presented in the area. We include the structure sensitive pigment index that gives us an idea about the variability in the vegetation. This is important because for some parts we have areas where we have forest areas and we have croplands, and for these areas, for example, the distribution of the vegetation was hard. Then this kind of index gives us an idea about the different kind of distribution between these different structure vegetation. And finally, we have the normal difference water index that identifies the presence of water, and it's important because, as I mentioned before, we have these estuary areas with the high or low tide. That means that there is or not water in the field. This is an example of the normal NDVI, that is the vegetation index I mentioned to you before, that gives us an idea about the condition of the areas for different periods of the year. Then we have the vegetation NDVI for the autumn, for the summer, and for the spring, and for the winter. And as you can see, the green areas are linked to the condition of the vegetation. Then especially the vegetated areas have the strongest greens in comparison to the other areas. And in the same way, the level of this green is different in the different periods of the year. This is a representation of the seasonality behavior of the vegetation. And then we have the information collected in the field. The people that were coming to tag the vegetation or tag the birds in the areas, they collect information in the field for us and gave us an idea about what was the kind of classes that we were mapping with the vegetation, with the air observation data sets. Then this is the scheme that we use for monitoring the change of the dynamic of the habitats in time. As I mentioned to you before, we use the Landsat constellations. We make a pre-processing to link this Landsat information to the areas of analysis. We calculate the same radiometric index in the past to identify the change, and we develop a chain detection algorithm based in these input data sets, and we apply the machine learning approach to map those areas in time to see if we have the same kind of classes in the past, and to understand if we have any kind of particular change in the past. These are the historical satellite images that we use for mapping the current and situation and the monitoring the situation in the past. This is an example of the change detection algorithm that we use. Is the analysis that we use to map the situation. I'm not going to be really deep in this kind of information, but just to give you an idea that with this kind of analysis, we map the interannual change that is linked to the seasonal behavior. We might the interannual change that is giving us an information about the potential change in different in the years and time, if there is a big change in times related to the vegetation, that this kind of change are normally linked to climates or any kind of inputs, different inputs, and the intra-annual changes are linked to the seasonal behavior. This is one of the area that we mapped, the Baltic area, and it's the Westford area. Both of these areas in Ireland are mainly covered for improved grassland, as you can see, but we have another different type of classes. This is the area, that is a particular area that is have a different distribution of the classes, and the interesting thing of this area that is different is that the species are not coming in land as in the ID sites, because they are more interested in the estuary area, and this is probably linked to the fact that the classes are different in this area. And this is the Kefni area that have this different distribution, have more woodland and scrubs in the field, and less improved grassland in comparison to the ID sites. The findings that we get from this project: the study of key habitats is essential to understand the relation between the species and the natural environment. Air observation is an essential and useful tool for monitoring the habitats, and large and inaccessible areas could be reached during different moments in a year without disturbing the species presented in those areas. And the air observation tools are a powerful tool, but needs interdisciplinary cooperation, needs information from the field, and need people working and giving us the additional information to have meaningful information to the people that is taking or is making decisions.